yesterday a little bit at when we plot one of these tables of points, so a number of points in a row, sometimes they join together to form a straight line, and that line is called linear. Lena, you question?
No, I just pressed it by accident.
Okay, no problem. Okay, so we can see that this is the formula for this line, this formula, and this is what we did yesterday. And then we did another one where we had a table. We created the formula, and we also created this line based off the points, just put them together and drew the line. And that was yesterday's work. So perhaps you recognize, and this is today's title.
Do we have to take notes on this?
Yes, please. So we're looking at equations of straight line. Now, yesterday, that's exactly what we did. We just had points, a set of points in a table, and then we looked at the equation. And of course, equation is another word for formula, I suppose. We use formula, but it's an equation. So you could say that's a formula as well. All right, so far, the two formulas we looked at yesterday was y is equal to negative x plus 4, and y is equal to 2x plus 1. And they both were formulas for straight lines. Does that mean I can say in general that anything that's written y equals something x plus something is a formula, as long as the two somethings are numbers? And the answer to that is yes.
Yeah.
These numbers are very useful and specific for helping us draw the lines and plot those points, put them onto a coordinate diagram. All right, so these two are very important. In maths, we don't say something x plus something, we give them letters. We call this one m, and this one c. So m, remember with the formulas, we created what the multiplier of x was going to be by noticing the pattern of for every change it goes up 2, you know, the rule was 2, so that's called the letter m is used for that, and c is used, yes, write this down, this is notes. Okay, now when we look at a line, we'll come back to this page in at the end. So have this much taken down, and then we're going to pause. I'm going to switch screens. So have that much taken down, and I'll get ready to switch screens here.
Can you show the title again?
Equation of a straight line. Okay, so I'm going to just turn off the camera on this one and switch. Apologies. All right, so hopefully now you can see some sort of graphing screen, and you're pinned on that. So can someone just say that you're seeing the screen that says Desmos?
Yeah.
Okay. Yeah, thank you. All right. So what this is, Desmos just does what we did yesterday quicker. So here's our formula, and it wants to put all the points. It puts it in a table for us. You can actually see if I do this, I'm going to want to, you won't have to do this, but I'm just going to convert that to, you see the way Desmos actually does the table of dots for us. Okay, and then if you want to, sorry, I'll get rid, I don't want to show that anymore. If you want to then plot it, you just you could click on it. You can see what it looks like. So that's all those dots joined together. So I'll show you that table again for that one. And it's just those dots joined together. Okay. All right. So that's a general look at what the line looks like. So now we're going to notice some things about this last number. So this is just y is equal to x plus 2. So the multiplier in this formula would be 1. Okay. So let's look. This most also does this thing called a, where I can change a constantly. So I'm just going to set a to 2. So okay, so I'm just going to, so it's the same line at the moment. I just, a is 2. But what you can notice here is I can change this constantly. Watch the way the graph changes. So as a changes, so for instance, when a is 0, let's get 0 here. There's a when a is 0, so that would be just y is equal to x plus 0. Let's have our original here as well. So that's y is equal to x plus 2. So if I move it on, oh, it crosses over there too because it's the same line. And then y is like 5. It's there. Does anyone notice anything about a? Does it? Can we relate it to anything on the graph? Does anyone notice that? No? Okay. So no one say anything, but I want you to notice. I'm going to zoom in a little bit. Whoa. So you can just see the scale. I want you to look at the y-axis. Yes, this axis here. This is the y-axis. Watch what happens when I move the a scale. So this is that. What's the graph doing? When this is at 3. This is it at 2. This is it at 1. Okay, type it in then, Reese. Type it into the chat. So it's kind of a cool function here. I can just let this play from -10 to +10. You can see that it moves off the screen, but it goes down as a is changing. It crosses the y-axis at whatever point a is. So whatever this last point here is in your formula, it will be the, yeah, thank you, Reese, got it. That will be the where it crosses this y-axis. So when I had that as C in my notes earlier, that's where it crosses the y-axis, this last number. So that means if I can remove this line, I predict that this line will cross the y-axis at 1 before I graph it. So I'm going to click this button, and then we're going to graph it. And hopefully, it will cross here. So that's halfway. Let's get 1 up on the scale. So I am fairly confident it's going to cross here at 1. I'm going to click it. Boom. Crosses at 1. And if I change that to -1, it crosses at -1. So that's kind of cool. The y-intercept, it's called, where it crosses the y-axis, is whatever this last number is. So I don't need to plot all these individual points. I know where it just crosses the y-axis straight away. Okay. What about the number in front of the x? So we know what the number at the end does, or hopefully you know, that's where it crosses. This number at the end is where it crosses the y-axis. This number at the start, multiplying x, that's our multiplier. Remember, that was our rule. 2 times or 3 times, or adding 2, sorry, adding 3. How does that affect the graph? Well, let's have a look at a couple. So this is the one with 2x. This is, okay, let's make it the same. No, didn't mean to do that. Let's make it 2x plus 1. So it's the same line I can compare it to. 3x plus 1. Okay, so there's 2x plus 1 is this one, and 3x plus 1 is this one. Okay, what happens when I do minus 2x plus 1? Okay, they still all go through plus 1, but they all go off at different directions. I think this is going to require me to do some slider work again. So I'm going to just look, and there's 2x plus 1. And now I'm going to look at moving it from, so this is when b is 1. So I'm just looking at this b here. I'm going to change it based on the slider. Oops. Okay, so let's move this slider. Notice what happens. We're looking at this line specifically. Notice what happens. All right, sorry, I was talking to Mr. Green, the famous. Yeah. So he was just apologizing for some of you guys being late, so that's cool. Yeah, so Reese has noticed, and maybe you could see that the kind of angle of the line changes, and it kind of spins around. It spins around. Yeah, never quite reaches it. Never quite reaches the other side, but perhaps if that slider was bigger. But it definitely still crosses at 1. All right, let's focus on. Let's put it at 0. So that's when b is 0. So you 0x. That'll be 0 times x. This is it as 1. Okay, so let's maybe look at, let's call this, when we do this, maybe the steepness of the angle. So remember, it was flat at 0. Flat at 0, it's going up at 1. What does it get even steeper at 2? Oh, it is getting steeper. You already knew that because 2 is there. Getting steeper at 2. It's even steeper at 3. What about 4?
The higher the number, the steeper it gets.
It's getting steeper and steeper. Is it ever going to go beyond? Is it ever going to go beyond vertical?
No.
I don't think it is. I think it's getting really steep, but I think it's going to stop at vertical. Let's go backwards to 0. Okay, and this is negative now. Now it seems to be going the opposite. It's going downhill now if we're talking about gradients, I suppose, or slopes. It's going downhill. And the angle's pretty small here, but if I increase it downhill, it's doing the same thing. It's getting bigger and bigger angle. Yeah. So this b number, the number in front of x, which I probably should call m. I don't know why I called it. Yeah. I can go from negative 100, let's say, up to 100. Let's see what happens then when I switch. Let's watch it as it plays out. Whatever. Let's start at negative 100. Oh, it's swapped. So with really big numbers, it gets really steep, but it doesn't change very much. And just as it comes down towards the smaller numbers, it flips at 0, and it's perfectly flat at 0 if you watch that animation. Okay. So 0 tells me there is no angle, it's just flat. After that, it starts to increase. Now, let's look. Oh, so the rule here, if we remember, with the 2x one, the rule here was to add 2. And the m was 2. So is the slope or the steepness directly related to what we add as a rule? I think it is. Because notice here, for every 1 box this goes over, it goes up 2 boxes. 1 box over, up 2. It's like if you sub in x as 1, you have to go up 2. Think about that. X moves over 1 and goes up 2. Over 1, up 2. That's called the slope or gradient of the line. So if I change this m to 3, so that'll be this one here, when it goes over 1, let's just remove our one that's at 2, and this one. So in this one, the new one with 3, this goes over 1 and up 3 boxes. Notice that. When it goes over 1, it goes up 3 boxes. Over 1, up 3 boxes. So hopefully you've noticed that. So I'm going to switch cameras and go back to my notes page. Okay, so hopefully you saw on that Desmos program that, oh, do I leave? Do I need to leave? Okay. That this C tells us where it crosses, where the line, I suppose, when you join all those dots, it's a line and it's linear, where the line crosses the, well, remember it was where it crosses this axis. What was that axis? That was the y-axis. It's called the y-axis. Where it crosses the y-axis. So it tells you where the line will go through this axis. So this is back to notes, so do take this down. And the m, or the number in front of x, so we looked at 2 and 3, and then we had the slider going from minus 100 to 100. And the larger m was, the more steep it was. When it was 0, it was flat. So there's no steepness to it. But when it was 1 and 2, it started to increase. Remember the boxes. That thing is called the gradient. Sometimes called the slope or the steepness of the line. So it's how steep the line goes. The bigger the number, the steeper. And we saw that in the animation. So you could talk about angles there if you want. The bigger the number, the bigger the angle that line makes. Okay? So that means if I have I'll give you a second to take that down. Now, what I will notice to the side here, and you may remember that from our Desmos work, if it's a positive number, m, it goes uphill. Uphill. If it's a positive slope, it goes uphill. Now, +2 went that way, +3 went that way, etc. And +100 was almost vertical. If it's negative, it goes downhill, it goes that way. So negative goes a downhill slope, if you want. Reading it from left to right, like you read an English book, left to right. Okay, so there's some things hopefully you noticed from the little Desmos experiment we did. Which means now we can kind of skip the table part of our plotting points. Maybe we don't need the table anymore for our formulas and rules and so on. We can still use it if we want, but maybe we can get there a little bit quicker. So I'm going to look at generally y is equal to, let's say, 4x plus 5. Let's look at that. Let's try and do this without a table. We're going to try and put it on a diagram without a table. You don't need to take this bit down. We're just going to look at this. So just keep focused. I'm going to draw my coordinate diagram. Okay. 1, 2, 3, 4. -1, -2, minus. Okay. So here's my y-axis, my x-axis. All right. Type in the chat. What is the place where this line crosses the y-axis? At what number does this line, this linear relationship, this formula, cross the y-axis? Type it in the chat. Does anybody know? Nobody knows. It is referring to, if we look at our notes, this last number where the line crosses the y-axis. So the line crosses the y-axis at 5. Thank you, Lily. Someone said it eventually. And Elan. So it crosses at 5. And that's that bit of information done. Now the other thing, this 4, it's how steep it is. It's 4 steep. Now how did I do that on Desmos? It was, I counted the number of boxes, wasn't it? For every one I went over, it went up 4. Well, in the ones on Desmos, it was 2 and 3. I went over 1 box and up 2, or over 1 box and up 3. So maybe I'll just go over 1 box on X, and then up 4 boxes. 1, 2, 3, 4. Okay, this one's going to be off. Wow, what a terrible diagram, Mr. Collins. You've drawn 2 points off. So there's 2 points on the line. So I can join that a little bit together. Now, because it's a straight line, a linear relationship, it can just continue on forever. So I can get my ruler out, if I can remember where I left it. Nope, I'll have to use my notebook. I can get my ruler out. This is a ruler. And just, it's a straight line. It goes on forever, that direction. Now, maybe you don't believe me. So perhaps we create a table. Okay, so I'm going to get X and Y. Now, I know my rule. My rule is to add 4 each time, for the Y coordinates. So let's just pick -1, 0, 1, and 2. Now 1 and 2 should be okay. 4 times 1 is 4, plus 5 is 9. And then the next one up, I imagine it's just going to be adding 4, but we just check. 2 times 4 is 8, plus 5 is 13. So that is plus 4. That means going backwards. I don't need to do any more of those. I know that answer would be 4 less, I suppose, going this way, 5. And that answer is going to be 4 less, which is 1. Oh, hold on. 0 and 5. No coincidence here. When X is 0, Y is 5, which we kind of knew from this. The rule follows. It all works out. Plus 4, plus 4, plus 4. This one is at 9. That's okay. That's what I got. I got 1 and 9 when I went over and counting my boxes. Because 5 plus 4 is at 9. I kind of went off my scale then. But the next one over would be over 1 up 4. So over 1 up 4 would be at 13. So you can see the way the rule translates into what the graph of the whole thing would look like, the linear graph. Now what about this? -1 on X and 1 on Y. Well, unfortunately, due to my terrible graphing skills, it looks a little bit off. -1 and 1. It looks a little bit off. It hasn't quite gone through it, so perhaps my scaling wasn't perfect because I've used freehand for my scales. But it should go through. It should go through that as well and on its merry way. Okay. So that's just all new theory. So hopefully you've taken some good notes. This part here is crucial. So make sure that you have these because we're going to return back to that next week. For today, you've got 2 tasks. First task is